Hello everyone, my name is Ryan. Welcome to the FME training for Esri Utility Network Migration. I am joined today by Mark and Trent, who will be helping answer questions during the first 2 days of the training course, and then we'll be presenting days 3 and 4. Also helping us with QA today is Nampreet and Jovita, as well as Liz. Everyone say good morning to them. You may have noticed that you're muted. I'll talk about that in a moment. But first of all, I'll have Mark talk about the goals for this particular course.
Good morning, everybody, and thanks for joining us. We've got about 220 people registered for this course. We'll see how many of those show up today, hey?
Fingers crossed.
Yes, and many people from around the world, so thanks very much for getting up early or staying late if you're joining us from overseas. So the goals of the course are to go over what you need to know about the Esri utility network migration workspaces that we've been building with our colleagues at Esri. The goal of the course is to enable you to modify these workspaces for your particular data sets so that you can get data into the Esri utility network asset package and then import those into the Esri utility system. So we're going to introduce you to the key aspects of using FME workbench. This is aimed really at people who are newer to FME, but if you're also an existing FME user, I think Ryan is going to show you a lot of good tips on some of the new stuff in FME. I think we're using 2018.1.
2018.1, and there is a lot of new functionality for those who haven't used FME 2018 just yet.
Particularly around working with your workspaces and understanding them and debugging them, I think. So that's going to be interesting today. Tomorrow, Ryan will continue to review the primary transformation tools that we're using in the migration workspaces. And then on Wednesday, Trent will pick up and we'll do a deep dive into the water migration workspace. This is classified as a simple migration. So this is really focusing on the schema mapping aspect of the migration. And then we'll pick up from there on Thursday morning and do a deeper dive into the electric migration workspace, which is classified as a basic migration. And there we'll be looking at a bit more detail, picking up from what we did on Wednesday, which is around schema mapping. And we'll be looking at the details of building assemblies. So by the end of the 4 days here, if you stick with us, you should be able to edit the water, gas, or electric migration workspaces that you need to use to suit your source data, and importantly, understand the resources that you need to get going there. Not our goals for the next few days is to cover some of the Esri products. So we won't be covering working in Arc Pro or editing utility network data in that sense. We won't be discussing the nuances of utility network data models and schemas. That's something that you can take up with your Esri colleagues or your data provider or integrators. We won't be looking at the Esri Data Reviewer, which is a validation tool for your ArcGIS. But if anybody is interested in doing some validation work with some of the FME tools, we're happy to discuss that with you offline. We won't actually be doing the import of the asset package into the utility network, so that's a separate step. We'll just mention that a little bit in the next couple of days. And we won't be looking at the Esri tools, which are the utility network validation scripts. So those are kind of all outside of the scope of this training. We're going to be focusing on the FME tools here. So Ryan is going to kick off today and tomorrow with an introduction to Workbench and a dive into transformation tools. Wednesday, Trent is going to be looking at the water migration and schema mapping, and Thursday I will be helping you with the electric migration, schema mapping, and assembly stuff.
And we should mention that we'll be taking a short break of about 10 minutes once per hour as we go through the course.
And I think we all need them by then, don't we?
Oh, absolutely.
Yeah. Okay, so over to you, Ryan.
Okay.
And of course, we do encourage everybody to ask questions as we go.
Yes. We do have a questions panel in the GoToWebinar. I will be pointing that out again shortly as we review the interesting aspects of GoToWebinar, but we'll get to that in just a moment. So day one, we'll be doing an introduction to FME Workbench tutorial. I'll be taking you to this link shortly. We'll mostly complete this tutorial today. We will then be going over some key transformers and other assorted bits of Workbench functionality that will assist you on days 3 and 4. That's what we'll be covering on day 2. We have a list of training manuals. I'll circle back to that in just a moment. The sample data, which we use for this training course, is available for download here. And I'll copy this link out to everyone as well. So if you want to download the data onto your own machine, you can use that link there. That can also be helpful if you want to work through these exercises at a later time on your own machine. We are recording this course. It will be made available shortly after the end of class each day at this link here. Currently there's nothing in there because we haven't finished recording it, but if you go to this link, go to stage, channel, FME, Esri, UN, and I just chatted that out as well. You'll be able to see the recordings of each day. A reminder of this address will be sent out in a final email upon completion of the course. There's further resources here, but, oh yes, there it is. So today we'll be doing part 1. We'll be doing this tutorial, the FME desktop data integration tutorial. Let me copy this link as well and send that out to everybody. When you first get to that, you have to make sure you hit the read button. I'll also send this direct link out to everybody. So that should be in the chat now. So I'll be keeping my manual up on the screen for most of the course. Occasionally, I'll go full screen with whatever I'm demonstrating, but for the most part, I will be keeping the manual up on the left-hand side of the screen. It does have this table of contents on the side. Once I go a little bit further into this, I'll talk about how to hide the table of contents. You can either follow along with your manual on your own computer. If you have a second monitor, that will be useful. If you're dealing with a single monitor, it can be a little bit more difficult to deal with. You can also just follow along with the monitor or the manual which I have up on the screen. The lecture part of the manual, you can come back to that later on if you like. Most of this section is just there to convince you why you should be learning about FME. For the most part, if you're already here, you're kind of aware of that. So there's information about here is about what data integration means, why you may want to use it, and the such. Just the data integration might be worthwhile reviewing after class, but for now, we'll go straight to what is FME. So this is where we actually, I guess, truly begin the course. Before we do that, though, I had asked this briefly with a show of hands, but we'll do a quick poll. Please let us know, have you ever used FME before? If you've never used it once or twice, or you've used it many times. Well, it is a far more even split between those options than I expected today, but that's okay. Let's review what is FME. FME is a data warehousing tool for moving data around to solve the problems of data interoperability. Interoperability is basically the ability to share your data. Not only can FME move data, FME can translate data to different formats and also transform its data model and contents to meet a required output structure. This is why FME is sometimes called an ETL. It can extract, transform, and load data. Here at Safe Software, we offer a number of products around FME. FME Desktop is what we'll be using this week. This allows you to create your transformation scripts and run them, but also allows you to inspect your data before, during, and after a translation. We also have two additional products, FME Server and FME Cloud. Those are more for use at the enterprise level. If you've authored a large number of translation scripts and want to make them available to a wider audience, you can use FME Server to make your translation scripts available through a web interface. FME Server requires that you host FME Server on your own hardware. Nowadays, everyone's moving to the cloud, so we also have a cloud-based version of FME Server called FME Cloud. For FME Cloud, basically, we host the hardware. Well, actually, Amazon AWS does, and then you simply pay a per hour fee. I believe it's per hour. At the very least, it's a subscription. FME has a centralized model so that adding support for a new format is as simple as plugging it into the core engine. FME's rich data model allows it to support all possible geometry and attribute types, which allows you to compensate for differences in data type and format to create a seamless process which doesn't lose data. FME also allows you to transform and restructure your data during the translation process. With the various formats that we support, sometimes the type of data which you're reading in from one particular format type might not be supported by other format types, but we have tools within our authoring environment that allow you to compensate for that. The information may not stay in the same form, but you can convert the information so that it can be stored in the output format of your choosing. So we can translate the data from one format to another, but we can also transform the data itself so that it's compatible with the output format of your choice. So data transformation is ultimately taking the data that you have and converting it into the data that you want or what you need. Ideally, all the information on your data will be maintained, although how it is represented may change. When we talk about data transformation, there are two basic types of transformation: structural transformation and content transformation. Structural transformation ultimately is the schema of your data. The layer names, the allowed geometry for those layers, the attribute names, the attribute types, and any other rules or constraints that restrict your data. So we can transform the structure of the data, ultimately the structure of your output data. We can also transform the content of the data, the features themselves. We can change geometries, we can change attributes, combine things together, or split things apart. So this brings us to the lab. So FME Desktop is the focus of this course. It is used to create data integration and manipulation workflows locally. And that's what we will be focusing on for this course. We'll be taking a look at how you can quickly set up a translation and run it, how to generate your workspace, inspecting your data in the data inspector, editing the schema of the data, the structure of your data, and then working on the content of your data using tools called transformers. We'll then look at different ways that the transformers can process the data. We may be skipping over the coordinate system part of the exercise. For those of you who have used FME before, but perhaps have not used FME 2018, we'll also be talking about partial runs, which is a new piece of functionality for FME 2018. I'll also review, whenever possible, some best practices. There are some things that you should do in Workbench to make life easier for yourself and other people in the future. So the two key applications we'll be focusing on are FME Workbench and the FME Data Inspector. FME Workbench allows you to create translation workflows using an intuitive point-and-click graphic interface. FME Workbench is the primary tool for data translations in FME. The FME Data Inspector is a simple viewing application that allows quick viewing of data in any of the FME supported formats. It is used for data validation and QA by allowing you to preview your data before, during, and after a translation. For this course, we will be focusing primarily on FME Workbench and the FME Data Inspector. Before using Workbench, there's a number of key windows which are worth being familiar with. But before we do that, we should actually open up Workbench. When you have FME installed, you'll find it in the Start menu. You may have noticed that we have two installations of FME Desktop on these virtual machines. Now, usually, it doesn't really matter which one you use. But for those of you using file geodatabase readers and writers, this is actually very important. We have an installation of 64-bit FME Desktop and 32-bit FME Desktop. And which one you use depends on whether or not you're using ArcGIS Pro or ArcGIS Desktop. ArcGIS Pro is a 64-bit application. In order to use FME alongside ArcGIS Pro, you have to ensure that you're using the 64-bit version of FME. If you're using ArcGIS Desktop, then you have to make sure that you're using 32-bit because it's a 32-bit application. For this course, we are assuming that you're using ArcGIS Pro, and ArcGIS Pro is what we have installed on these machines. So make sure that you're opening up the 64-bit version of FME Workbench. So you can do that here through the Start menu. We also have it available on these virtual machines as a shortcut on the taskbar. So let's open up FME Workbench. Always important to do at the beginning of the course to find out if we have any issues with our license server. Fingers crossed we shouldn't be having any problems with it. Let's find out. The very first time that you open up FME Desktop, it will take a little bit of time to open. On these virtual machines, this is a fresh install of FME Desktop, so it does take a moment. There we go. From here on, whenever you open FME Workbench on your virtual machines, they will open considerably faster. So I'm going to put that over onto the left-hand side of my screen. I will keep the manual on the right. With the table of contents in the manual, if you find that squeezing your view too much, you can minimize it using this icon up here. Okay, first I'm going to review the components of Workbench and then what you'll see within Workbench. We have a Start tab, which gives you some useful links for getting started with FME. And the Main tab. The Main tab contains the canvas. The canvas is where you define your translations in the form of a flowchart-like setting, where the connections between each item represent the flow of data. Along the very top, we have a menu bar and a toolbar. The menu and toolbar has many tools for creating, editing, and running workspaces. On the left-hand side, we have a navigator window. The navigator window is an explorer-like tool which displays all of the settings and parameters which can be applied within the translation. Below that, we have a parameter editor. When I select an object, it'll give me the parameters which I can edit on that object. It's tabbed with the transformer gallery. These windows are often tabbed like this, so you can go back and forth. The transformer gallery is a window for the location and selection of different transformation tools. There's also a variety of other windows which will show up. When I run a translation log window will appear at the foot of the interface. And this displays a report on translation results, including errors, warnings, and statistics on the number of features processed. Okay, so make sure I haven't missed anything here. Workspace components. In the manual here, it also talks about readers and writers. Readers are objects in your workspace which will bring in data from your source data set. A writer will write it out to the destination data set. Once we've added readers and writers, we'll find them listed in the navigator window. Within each reader or writer, there will be feature types. These are your layers of data, your feature classes. So within a workspace, we can have multiple readers and multiple writers. Within each of those readers and writers, we have the feature types. Think layers or feature classes. And then within each one of those feature types, you have the individual features, your points, your lines, your polygons, etc. So within the workspace, it'll look like this. We have our readers and writers in the navigator, the feature types on the canvas, and then those are connected up to either go through the transformation tools or directly out to another writer feature type. So let's do a little bit of hands-on here. We're going to open up an existing workspace. We have this workspace here. I will chat that out to everybody. Open up Workbench if you haven't already done so. Remember, you can do that through this little shortcut on the taskbar. So let's find our beginning workspace. We can do that by going to the File browser or the File Explorer. So you have the File Explorer. We'll go to the local drive. On the C drive, we have FME Data 2018. This contains all of our data and our workspaces for this course. You can double click on that. We'll go to Workspaces. So that's C, FME Data, Workspaces. We'll go to Desktop Basic. And we have Basics, Exercise 1, Begin. You can double click on that. It'll ask you, what application do you want to use to open this file? We do not want the Windows 32-bit version. We don't want to work with 32-bit. We want to make sure that we're working with the 64-bit. So find FME Workbench 2018.1 Win64. Make sure you find the Win64 version, and then always use that app for the FMW files. Now, after this course on your own machine, if you're using a 32-bit version of ArcGIS, you'll want to make sure you're using a 32-bit version of FME Workbench as well. But if you're using ArcGIS Pro, make sure you're using the 64-bit version of FME Workbench. So we'll hit OK to open that up. So let's take a look at what we have in this workspace. In the navigator, we can see that we actually have 2 readers and a single writer. In the navigator, you can also expand any of the items or objects you see listed. This will give you further information about that particular item. So we can see that this is a file geodatabase reader. It has a number of parameters which can change how the data is being read. And we also have the feature types. These are the feature classes within this file geodatabase. We also have an AutoCAD file. The AutoCAD file also has a number of parameters which will change how that data set is being read. And it also has the layers within that AutoCAD file. And we can see that on the canvas here. We have our feature types. They are currently enclosed inside what we call a bookmark, so you can change the styling on the canvas, group things together, indicate what they are for. This is part of best practices. It's a good idea to use bookmarks and these comments that give you further information about what these transformers are doing to the data. So we can see that we're reading in these libraries. We're constructing a line between all the libraries with a line builder. Just takes our points, creates lines. We're also buffering the libraries out as a separate transformation process. So we buffer them out a certain amount. So we can see the buffer amount there is actually calculated based on a circulation attribute divided by 2000. With our line builder here, this is taking our libraries, then we have our roads all coming into a shortest path finder. This is finding a shortest path to the various libraries. And we have this object here. This is also a bookmark, but our bookmarks can be collapsed to save space. So within this collapsed bookmark, we have some additional transformers. We're using an attribute manager to rework the attributes and a string replacer to do a search and replace within an attribute to change the formatting of that particular attribute. For our buffer, we're also doing some attribute management and then writing that out to a shapefile. This is a feature writer transformer. This is a writer within a transformer. And that's currently writing out to a shapefile. It's important to note that when you're running a translation, there's no common coordinate system that's being used. We have data coming in from multiple sources, so it's possible that the data has different coordinate systems. This means that the X and Y coordinates of the various features will be quite different depending on the coordinate system. If we want to do any sort of comparison of the data spatially, it's important to reproject the data into a common coordinate system of your choosing. That's why we have this reprojector transformer here. It's reprojecting the data into lat long 84. We're then running it through some HTML generators to create some reports, sorting the data, laying it out, and writing it out to an HTML file. So let's run this translation. To run a translation in FME Workbench, you press the green play button. That's this button up here. You can also use the F5 key, or you can go to Run and run the workspace. So let's hit this Run button. You'll be prompted with a dialog. I'll talk more about this dialog later on. This allows you to change your source datasets or change the output dataset name at runtime. We'll just hit OK and run the translation. The translation log will appear. This will give us feedback as to what FME is doing. It'll tell us how many features are read in, how many features are written out. Also, if anything should go wrong during the translation, it should give us an indication of what went wrong here. So we've written out one feature to the HTML file. We can see the flow of features. We have 8 libraries coming through, a large number of roads. We build lines between them, and everything's written out. Once you've run the translation, you'll probably want to inspect the data. With some formats, we could just hit this button right here and inspect the output. but this is creating an HTML file. Best to inspect that in a web browser. So instead, we'll want to go out to the containing folder of our writer. That's this icon right here, Open Containing Folder. So everyone can click on that. And this is what we get. We have our shape file, which was written out with our libraries, and we have a library report. So I can double click on my library report, open that with Google Chrome. And this is the report that was generated by these transformers here. And it also gives us a map as well. So the goal of this exercise was just showing you that you can open up an existing FME workspace. You can then run it and then locate the output by clicking on the containing folder. So quick review, you can open up FME Workbench by finding it in the Start menu. We have our canvas here, which contains our source layers, our transformation tools called transformers, and our output layers. The menu bar along the top gives us many things we can do, such as run the translation. Notice we always end up with this little prompt. There are parameters that you can flag, you can publish, so that you're prompted for a new value. For today's class, that may be a bit of a pain. We can turn that off with this little icon right here. So I have this icon here. This is the prompt before running a workspace. We also find that under the run. We have the run with prompt. We can turn that off. Something which is also really handy up here under run. So we turn off the run with prompt. Let's turn on run with feature caching. Feature caching means that FME will cache all of the features at each output port. This allows us to inspect those features at that point or continue a translation from that point. When that's not turned on, FME does not have any intermediate data sets. So this is how FME is a little bit different from something like the model builder. In model builder, you'll often have intermediate file geodatabases. FME doesn't do that. Everything is stored in memory during a translation, and the translation goes all the way through. But sometimes we'll want to inspect what had happened to a feature in a particular transformer. To do that, we can turn on the feature caching. Now when I run a translation, it will cache the features at each output port of a transformer. So then I can run from this point in the translation. So I can make changes and then just run from here or run to this transformer. I'll talk more about that later. Again, we have the navigator, contains information about our various readers and writers, but also the transformers themselves. When your workspace gets very large, this can be a very handy way to find the transformers that you want or need to edit. When you need to find other transformers, you can find them in the transformer gallery. Also a good idea for each translation run to inspect the translation log window. Look for any errors. This means that something's gone very wrong with the translation and the translation was halted. You'll have to fix the cause of the error in order to run the translation again. There's also warnings. Warnings mean that something might not be right, but it could be okay. It's important to review the warnings, but not all of the warnings are actionable. We have 12 warnings here. If I click on this, it will just show those warnings. So the warnings that we're getting, feature caching is on. It's warning me that I've turned on this run with feature caching. It's warning me that because this does slow down the translation considerably. When you're authoring a workspace, I think that performance hit is well worth it. But if I was running this later on with a full data set or running this in production, it would not be useful to have that on. It would hurt performance greatly. And eventually you'll be dealing with very large data sets. And if you're not in the active process of authoring, it's best to turn that off. And it's telling me as such here. It's also giving me a warning about Python 2.7 support. I have that as my default Python interpreter. Eventually that's going to be deprecated. So it's just telling me to consider changing that. And then just more information about the caching. So I can ignore all of that. Later on, we'll see some warnings which are more important. So we've seen creating the opening up an existing workspace. Let's talk about creating your own workspace. Generally speaking, you'll start on the Start tab. Here you can start with either a blank workspace using the New option, open an existing workspace with Open, or generate a workspace using Generate. When I click on Generate, it'll bring up the Generate Workspace dialog. This will prompt me to select a source dataset and a destination dataset. I can then choose the format that I want, and I can do that either from the drop-down or just start typing in the name of the format. File GeoDB, and there I can see all of the file geodatabase formats. I can then select my dataset, select the output, and then hit OK. I'll then be presented with a feature types dialog. If there's multiple feature types, multiple layers or feature classes within the dataset. Because quite often you don't actually want to translate all of them. So it'll ask you which ones do you want to translate. I can then select the ones that I want and hit OK. And it will create the new workspace. It will bring in my reader feature types on the left. These are my reader layers or feature classes. And then it creates, as best it can, output definitions, output feature type definitions on the right-hand side. It's then important that you save your workspace. When you save your workspace, a recovery file is generated. Then, if something should happen, power goes out, something happens to FME workbench, the next time you go to open up that workspace, it will notice a recovery file, and it will ask you to recover any unsaved changes. If you haven't saved your workspace, that recovery file is much more difficult to find. Again, you can run your workspace by hitting the green play button or going to the Run menu. The Run menu allows you to turn on various run options. For this course, for the most part, we'll have the Run with feature caching turned on. I think of this as running in authoring mode. You then run your translation and you get your workspace results in the translation log. It will tell you how many features were read in and how many features were written out. Again, it's very important to also consider the warnings. So let's move on to exercise 2, basic workspace creation. So let's take a look at exercise 2. In this particular exercise, we're going to take a MapInfo tab dataset containing zoning data, and we're going to create a translation to convert that into GeoJSON. If you have not already done so, open up Workbench. In the Start tab, or by going to File, Generate Workspace, or hitting Control-G, you can bring up the Generate Workspace dialog. So let's click on Generate Workspace. Our source format will be MapInfo tab, My tab. We can find the format by typing in MapInfo. This will narrow the list down to the various MapInfo formats. And then we can select the MapInfo tab, My tab, Reader. We then have to find the source dataset. Clicking on the three-dot button will open up the file browser. The location of the data is C, FME Data 2018, Data, Zoning, and in the zoning folder, we have a zones.tab file. So over here, we can type in \, that'll take us to the root, FME, and that'll suggest the FME data. A down arrow to select it will fill in the rest of the path. \ again, D for data, again, a down arrow to select data. \ again, a Z for zoning. And then if we hit enter, that'll take us into the zoning folder. We can now select the zones.tab file. And then we can hit open. When configuring a reader or a writer, it's important to always double check the parameters. Some formats have nothing to really set. This is an example of that. There's nothing important for us to change here in these parameters. But other formats may have important parameters that you need to set here. And it's important to set those parameters here because this data set will be read in to create the initial workspace. And if you do not set the parameters correctly, the source data set may be read in incorrectly. And then the workspace, your initial translation script, will be generated incorrectly. So it's always a good idea to review the various parameters, see if there's anything important to change. For the MapInfo tab file, there isn't, so we'll just hit OK. The next important thing to check is the coordinate system. As I mentioned before, there is no common coordinate system used within Workbench. The data is simply read in, and the coordinates of the features, the X and Y coordinates, are used. The coordinate system is information defining how those coordinates were derived. If your data is in different coordinate systems, you will not be able to do spatial comparisons until you get them into a common coordinate system using a reprojector transformer. And the reprojector transformer will only work correctly if the features know what coordinate system they are currently in, and that is set here. Read from source. Some formats store the coordinate system information in the data itself, so it can read the coordinate system from the data. If I was reading in a different data set, like an AutoCAD file, this would say unknown or undefined, because the data set itself does not know the coordinate system, and I would have to specify it manually. So always check here to see that it says read from source. If it doesn't, consider the necessity of setting it manually. We've configured our reader. Now we need to configure our writer. We are going to write out to GeoJSON. So I'll type in JSON, and we'll choose this one here, GeoJSON. Again, we'll click on the file browser for the output dataset. And we're going to write this out to C FME data 2018 output training zones.json. So that's backslash FME data 2018 backslash output, O for output, backslash T for training. We'll go into that folder. And now we need to supply the name of the file, which will be zones.json. I'll give everyone a moment to fill that out. We'll hit save. Again, double check the parameters. There's often important things to change here, but in this situation, I think all the defaults will be okay. Coordinate system, same as source. Good enough. Workflow options for everything that we'll be doing, we'll be sticking with the static schema. And we hit OK. This will generate our initial translation script. Now, it doesn't tell us to do this in the manual, but the very first thing that you should do once you've created your workspace is save your workspace. So go up, click on the save icon. Because we had opened up a workspace previously in FME data, it went back to that location. We'll want to save our workspaces somewhere else. Let's click on Documents, Documents, FME, Workspaces. So Documents, FME, Workspaces, and then we can save our workspace. By default, the name of the workspace will be the name of the reader to the name of the writer. But we can give it a different name. This is exercise day 1, exercise 2, so exercise 1.2, and we'll save it as such. So you can see we have a bookmark already here with our source layer. You can click on that, move it around a little bit. There's this little triangle here that will expand that feature type definition. We can expand it on the writer as well. We can see that it contains 2 attributes, zone name and zone category, and those have also been defined on the output. We can then run our translation by hitting the green play button. Here we can see it read in 416 zones. And in our log file at the bottom, again, we have a number of warnings. We can take a quick look at those. Those are all the usual feature caching warnings, just warning us that perhaps this translation is not running as fast as it could. We can see here that it read in 416 features and wrote out 416 features. If we wanted to locate the output, again, we can click on the Open Containing folder, and there we can see our zones JSON file. We'll take a look at inspecting that in an upcoming exercise. So we've created a workspace from scratch, and we've run the workspace and located the output file. So we've translated our data, read it in, wrote it out to an output file, found the output file, but we've never taken a look at our data. We've never inspected the data. Ultimately, data inspection is very important. Data inspection is simply the act of looking at your data before, during, or after a translation. Specifically for verification and debugging purposes, you can take a look at the format of the data. Is it actually in the format you expect? The schema, does it have the layer names, attribute types that you expect? Is the geometry correct? Does it actually have points or polygons as you expect it to have? Is the symbology correct? Coloring, things like that. Do the attributes have the values that you expect it to have? Do we have the right amount of data? Sometimes things can go wrong and you'll end up with far fewer features than expected. And ultimately, is the output all configured the way that you want it to be? So we use data inspection to ensure all of those things are actually happening. We can do that using the data inspector. There's a little icon down here next to workbench. You can click on that now to open it up. While that's opening, we'll talk about what the data inspector is. The data inspector is a simple viewing application. It allows you to see everything that FME knows about a particular data set. The data inspector is not a data editor. We cannot edit the data. We cannot perform complex queries. We cannot create cartographic output. It is simply to do a reality check to make sure the data is what we expect it to be. Just going to quickly go over here. I have my zones here. You don't have to do this part. This is just so I have something to show. I'm going to drag and drop my zones JSON in here. So that I have something to show. Oh. Drag and drop often guesses the format. Sometimes it guesses it incorrectly. Let's change that. There. So here's the JSON that I just created in my most recent translation. And we'll use this, or I'll use this, to review the major components of the FME data inspector. We have a menu bar and a toolbar along the top. It allows me to query the data, zoom in, zoom out, pan around, zoom to selected, etc. Open up additional data sets, add data sets to this view. The typical tools of a GIS, but keeping in mind that that's as far as we can take it. We can't edit this data or anything like that. So the menu bar, the view here shows us the geometry. We have a display control window along the side here. We can turn layers on or off. If I have multiple layers, I can drag them up or down, which will change the drawing order. When I select a feature here, you'll also notice that it selects it in a table view of the data down below. I can also select features in the table view. The table view only shows us the user-defined attributes, but there are more attributes available on these features. The, advanced or additional attributes you'll find in the feature information window. Make this a little bit bigger. In the feature information window, we find information like the layer that this feature belongs to, the coordinate system of this data. Is it 2D or 3D? The extents of the data. We also have an attribute list. This will list the user-defined attributes, but also any additional attributes FME creates based on the format type. We call these format attributes. It's with these format attributes that FME allows you to maintain the intent of your data during a translation. It stores all of the, format-specific information as a format attribute, and then you can rework those format attributes. There'll also be the geometry information for this particular feature. So again, the view window just shows the geometry. The menu bar and toolbar allows you to navigate around the geometry window, but also change window setups. There's a simple measuring tool for measuring distances. There's a filter here for filtering out various features, etc. The display control window allows you to turn layers on or off. You can also click on the number there and select all those features. If I click on the little icon right here, I can also change the styling if I don't like the default styling. Keep in mind you should not be creating cartographic output here. This is simply for debugging or inspecting the results of your translation. Feature information window shows additional information, the complete information for that particular feature. If you know that a particular piece of information should be on a feature and you do not see it here, that means FME simply isn't seeing it at all. The table view just shows the user-defined attributes and also allows you to select features. I opened up this data set by dragging and dropping it. We can also click on this icon here or go to File and open a data set. This will open a data set in a new tab. So there's my new tab. These tabs are completely separate. What I do in one tab does not affect the other tabs. If I wanted to add a data set to this view, I could click on the Add Dataset icon or File, Add Dataset. This information tool here allows me to select the features. If I want to select a feature, I have to make sure that is selected. I can also pan around, zoom in, zoom to selected area, zoom out, zoom to extents, or zoom to a selected feature. If I want to measure distances, I can use this icon right here to measure a distance. You'll notice that I can't measure around a perimeter. It's just click and drag and it gives me the distance between those 2 points. The distance shows up down here or in the log window. A limitation of this is that it will give you the distance in the coordinate system of the data. So for this data set, it's giving me the distance in decimal degrees. Not particularly useful, but that's just the way it is. So the feature information window gives us more information. Table view, again, just the features or just the attributes that the data has. When you select a feature up here, if the table view has not been added, it will add it. If you open up a large number of data sets, it will not open up every feature class or feature type as a tab. You may have to select it from the drop-down in order to bring it in. So you can see here we got these 2 tabs here, accessible parking and libraries. Quite often you have to add those manually, or if I select a feature up here, it will bring it in. Background maps are very handy. Background maps can give your data some context. Background maps will only work with your data if your data is coordinate system aware. When you're adding the data, you saw the coordinate system read from source, or if it was unknown, you defined your coordinate system. I can go to FME options. I have my background map. You'll be turning this on in an upcoming exercise, so you don't have to do this right now. But I can go to STEM and Maps. This is, as far as I can tell, the only free one, but we also have ArcGIS Online Maps if you have an account with that. I believe we do here at Safe, but I cannot remember the username or password for the life of me, so we'll use STEM and maps today. Under the parameters is where you would set things like your username and password. Also, the various map servers will offer various maps, so you can choose which map you want here. Takes a little while. I'll choose terrain for my map. Okay, and that will apply the background map to this tab and any subsequent tabs that I open up. As I mentioned earlier, the tabs are sandboxed. They're all separate. I have not set the map in this tab, so it doesn't show up here. It'll just show up in this tab and any additional tabs I add. Again, with your data sets, very important that they have a coordinate system set. Okay, so let's inspect the data from your previous translation. If you've not already done so, start the data inspector. We will then open a data set. So go up to File, Open Dataset. The source format will be GeoJSON. It may or may not already have that entered in. If it doesn't, type in GeoJSON. And then select your output JSON file. So that should be in /FME data 2018 /output /training, and in the training folder you should have your zones JSON file. I'll give everyone a moment to select that. I'll open this up. Notice it does not say that it knows the coordinate system. I think because it's lat long, it might get away with that. But if you do see unknown, good idea to enter in a coordinate system. We'll use LL84 and hit OK. You notice the background map for me is turned on. You don't have the background maps yet. We'll turn that on in a moment. And you can click on some features and you'll see information about that feature. We'll now want to add an additional data set to this view. So we'll use the file add dataset. Our source format this time will be KML, Google KML. So remember that's file, add dataset, and then selecting Google KML. And then we need to find our KML file. And that is FME data 2018 data boundaries, Vancouver neighborhoods. So /FME data 2018 /data /boundaries. And in the boundaries folder, we have our Vancouver neighborhoods KML file. I'll give everyone a moment to find that. And we'll open that up. Coordinate system, it'll read from source. And that brings in our Vancouver neighborhoods. Notice here in the table view, we don't see the neighborhoods just yet. We can add it from the drop-down or select one of the neighborhood features. Or if we're not sure where the neighborhood features are, remember up here in the view, we have our neighborhoods and it tells us that there's 6 features here. If we click that, it will select all 6 features and that will open it up in the table view as well. So now I have my neighborhoods and my zones table views. When inspecting the data, quite often the coloring that it has might not be helpful for inspecting your data. So we can change the styling. The styling icon here is this little 4-quadrant square. If I click on that, I can change, in this case it's an area, a polygon. I can change the pen color of the outline, or I can also change the fill color as well. So I can choose a new fill color. I'll choose orange. So remember, that's just clicking on this 4-quadrant square beside fill color, clicking the little button there, choosing a different fill color. We can also change the opacity and apply that there. So now we can see those zones much clearer. Or sorry, those neighborhoods much clearer. Now, if I'm trying to select a zone in the background, sometimes this will work well, sometimes it doesn't. Perhaps I want to see the zones brought forward. Again, we can do that by setting the draw order. It's just clicking and dragging the data sets. So you can drag these up and down to change the draw order. Now you can set the background map. Let's go up to Tools, FME Options. Under Tools, FME Options, we can go to the background map. The one that you're going to want today is the Stamen Maps. So that's Tools, FME Options, Background Map, Stamen Maps. We then check the parameters. That will allow us to choose the correct map. You can choose terrain or any of these that you like. I find watercolors actually kind of pretty. So I can hit OK, and that brings in my watercolor map. Again, note that it's different in these different tabs. Any tab I open up from now on will use the watercolor map. Previously, I had the terrain map. So that gives a good overview of inspecting your data in the Data Inspector. So let's continue on. Earlier, I was talking about different transformation types: structural transformation and content transformation. Structural transformation is changing the structure, the schema of your data, the attribute names, the layer names, and attribute types, allowed geometries, things like that. That is a structural transformation, and the content transformation is changing what's on the feature itself, the geometry and the attributes. We're going to take a look at the structural transformation first. So the schema is the formal definition of a dataset structure. The schema consists of the layer names, attribute types, allowed geometries, and any other rules or settings that define or restrict the data. When you first create a workbench workspace, FME will add the source schema to the left-hand side of the canvas, like what we see here, and then creates, as best it can, a copy of the source schema as the destination schema. This is just a definition. It hasn't actually created the output until you run the translation. You can open up the properties of the reader feature type to see more detail of the schema. There's a few ways that you can do that. You can click on the little gear icon here, or you can right click and choose properties, or you can just double click on it. That's my preference. When you double click on your feature type, you'll get this feature type dialog. This will give you further information. The name of the table name or feature class. This value here will change depending on the format. We call everything feature types, but in various applications they have different names like table name or feature class or layer or level or sheet or things like that. It will also tell you the reader that this particular feature type belongs to and allowed geometries. Some formats allow any mixture of geometries per feature type. Other formats only allow a single geometry type per feature type. Under the user attributes, you'll be able to see the attributes which exist in this data set. We have our zone name and zone category and the attribute types. You can see those here as well. You'll notice that these are grayed out. We cannot edit these attribute definitions or what's here. These simply reflect what is actually in the data set. The writer schema also lists the feature type name and the writer and the attributes, but you'll notice these are not grayed out. I can edit these. So I can come in, I can change the output feature type name. If I have multiple writers, I could move this feature type from one writer to another. I can also delete or add or rename various attributes here and change their types as well. Editing the output feature type definition, the writer schema, is schema editing. In order to transform the schema of the data, you must edit the destination schema. That is simply the act of editing the attribute names, attribute types, and the name of the feature type or layer itself. This is your structural transformation. You can also change what geometries are allowed in the feature type if necessary. So the feature type definition and geometry type changes. With many GIS and CAD formats, it's not necessary to pay attention to this, but for Esri shapefile and file geodatabase, this is extremely important. If you do not set your output feature type allowed geometry correctly, you'll end up with a lot of warnings in your translation log, but the translation may or may not actually fail. Now that can be unfortunate. If you end up with a large number of warnings and the problem is the allowed geometry, what's actually happening is a feature is being sent to the writer. The writer is recognizing that it's not the correct geometry and it's just warning you, hey, this isn't the correct geometry, I'm not going to write it out. So you end up with a translation which at the very end says it was successful, but it didn't actually write anything out because the allowed geometries were incorrect. So pay special attention to this on your destination feature types, and we'll see this in upcoming exercises. This brings us to exercise 4. For the next couple of exercises, we're going to be building upon this initial workspace. We're going to be reading in a map info tab file that contains city parks. Ultimately, our goal is to calculate the size and average size of each park in the city for grounds maintenance estimates. During this process, we are going to perform a structural transformation, but also a content transformation. We're going to change the output structure for the writer, and then we are going to rework some attributes, filter out some features, perhaps create some additional attributes and some annotation as well. So let's begin. Go to Workbench, go to the Start tab, and click on Generate. And save your existing workspace. Our source data set is a map.info tab file. So that part here in the Generate workspace we can leave alone. The source data set, however, is not the zonings tab file. It is a different tab file. It's parks.tab. So let's click on this three-dot button here, open up the file browser. And what we want is FME data, data, and in the data folder, we have a parks folder. So go to the parks folder. And we'll choose our parks.tab file. Always double check the parameters, nothing to change. Coordinate system, read from source, that's good enough. Output format, map.info tab. Most translations, which are done in FME, start and end in the same format. FME is being used to transform the content and the structure of the data, not necessarily the format. So our format is map.info tab as well. The writer dataset, it will be going out to \FME data 2018, \output, \training. We're not specifying the name of the file here itself. Map.info tab files are similar in structure to Esri shape files. Each individual file is a layer, and they're all being kept in a folder. So the output dataset is a folder, not a specific file. Check the parameters. Again, nothing to change. Give everyone a moment to fill that in. And then we'll hit OK. Now remember, the very first thing you should do when you create your workspace is save your workspace. So let's go click on the save icon. We'll call this exercise, it's day 1, exercise 4, 1.4. Okay, so before we get to the renaming the feature type, I'm just going to move some things around in my workspace. I'm going to be working in this for a while. All of these windows here are dockable. I can pull them out. I can move them somewhere else. Because I am dealing with such a small amount of space here. I don't have a large monitor and I'm dedicating half of it to my manual. I'm going to try to make this canvas part much larger. So I'm going to pull out all of these windows here and I'm just going to tab them over top of my translation log. There, that way I can still get to them if I need to edit something, but it gives me a much larger canvas. So I still have my navigator, transformer gallery, translation log. The parameter editor I never use. I'm just going to close that entirely. There we are, navigator, transformer gallery, translation log. And now I have a bit more space for my canvas. Now, first step, structural transformation. We're going to rework the output schema. Find your Parks output feature type and double click on it. That'll open up the feature type dialog. So this is the feature type dialog for my Parks output feature type. Here I can change the name of my output feature type. I'm going to call this Parks Maintenance Data. If this was an AutoCAD file I was writing out, that would be the name of the output layer. If this was a file geodatabase I was writing out to, this would be the name of the output feature class. If this was a shape file, it would be the name of the shape file itself. Writer, that's correct. If I was writing this out to a file geodatabase or an Esri shapefile, I'd also want to double check the allowed geometry as well. Make sure that is in fact correct. We'll now click on the user attributes and take a look at the attributes. These are all the attributes which are on the source feature type, so let's copy them over to the destination feature type. But these are not all the attributes that we're interested in. We actually don't care about the reference park ID. So you can highlight that and then either hit delete. That's if delete will work. Sometimes I have luck with that, sometimes I don't. Can I delete? Nope. Okay, so select reference park ID and hit the minus sign at the bottom. And that deletes the attribute from the definition. Park name, we still need. Neighborhood name, we're actually going to rename this attribute to be just neighborhood. So just delete the name part off the end. So we have park ID, park name, neighborhood. Visitor count, we don't care about. Tree count, we don't care about. Dog park, we don't care about. Washrooms and special features, we'll delete all of those. So you should now have park ID, park name, and neighborhood. For our groundskeeping, we also want an attribute of park area. We also want to know the average park area as well. So on this bottom line here, let's just click on it. And then we can type in park area to define a new attribute. For the type in the dropdown, we'll choose float. The attribute types here in this dropdown, they vary by format. So when you open up or when you add writers of different formats, in this dropdown, you'll see different attribute types. So we'll choose float here and average park area. Also float. So that'll give you what you want. Oh, they left tree count in there. Well, I don't think we ever use that, so I'm going to leave those out for now. If necessary, we can come back and add those back in. Let's hit OK. Now you'll notice that I can resize things like the bookmark here. With my destination feature type, notice that the name's too long to fit in here now, so it's being truncated. You can resize it by using these little gray lines at the end here, so you can resize that to fit. If I double click on that gray line, it'll snap it to fit. So now what we have is this. Now in the manual, it tells us that we can hide attributes on the source feature type. We can unexpose them. This simply hides them from the interface. It does not remove the attribute from the feature. With the data volumes that you'll eventually be working with, it's a better idea to actually remove the attributes you're not interested in, as opposed to just hiding them. Now, if you're reading in from a database, sometimes this option of going into the source feature type, going to the user attributes, and unselecting these attributes will prevent that attribute from being read in at all. That's a good thing, but it only works if you're reading in from a database. For a file-based format like this, all the attributes will be read in regardless. It may be worthwhile to remove them entirely, and we'll take a look at how to do that later on. So we're going to skip step number 4. Let's save our workspace. We'll continue on with this later on. Once you've edited the schema, like we've done here, it may be necessary to map the schema or connect the old schema to the new schema. I just deleted the connection there just so I could demonstrate this. There's 2 levels of this: feature mapping and attribute mapping. Feature mapping is connecting your feature type to either another transformer or an output feature type. It's these thick black lines. You can do that by hovering your mouse over a port, clicking, and then dragging a line to another port. When you get close, it'll snap to it. That's the feature mapping. You can also do it just by clicking so that it's selected, and then clicking on where you want it to connect. That's actually my preferred method, because quite often what you want to connect to could be very distant on the canvas. So I can click on a port, navigate around the canvas to what I need, and then click on it again, or click on the port I want to connect to. Merging and splitting of the data is permitted. I could have multiple feature types all going into a single one, or use transformers to split them apart. If I have an additional connector coming out of a feature type or transformer, it actually creates a copy of all the features. A copy of all features will go along each feature connector. Once you have connected the features using a feature connector, you can then do the attribute connections. Now, this is optional. You can also do this in transformers, and in my opinion, using the transformer is a better way to do it. But I could take my neighborhood name here, so I can see neighborhood name, and I could map that directly to neighborhood. That does work, but this method of mapping your attributes is fragile. If I delete that connector and then reconnect it, that mapping is lost. In my opinion, it's better to use some of the transformers for mapping your attributes, and that is what we'll be seeing in the next exercise. You will note that the triangles here are color-coded. You should pay special attention to those color codings. Green means that the features coming in have park ID defined on them. Park ID and park name will be getting values. There's nothing defined for neighborhood, park area, or average park area. If I run the translation now, those attributes will be given null values. Red triangles are almost always a bad thing. You'll often find yellow triangles as well. Yellow triangles mean that this attribute is defined in the source dataset, but it's not mapped to anything in the final output. You should be aware of that, but it's not always a bad thing. Quite often there are attributes that you're simply not interested in. Let's take a look at exercise 5. So we'll be continuing on with our previous workspace. Right now we have parks, going to parks maintenance data. One of the things that you may notice is that we have neighborhood name here with a yellow triangle and neighborhood here with a red triangle. I had mentioned that the best way of handling attributes is with transformers. There's a number of transformers that we can use to rework attributes. In situations like this where we have relatively few attributes, the attribute manager is the best transformer to use. In tomorrow's session, we'll talk about some alternatives to the attribute manager and why you might want to use them. But the first go-to transformer you may want to think of whenever you have to work with attributes is the attribute manager. So let's add a transformer. The way we can do that is click on the feature connector. This is where we want the transformer to be added. And then we simply start typing the name of the transformer we want. When we start typing, a quick add dialog will appear suggesting transformers. So if we start typing in, and it says attribute manager, but it does partial name searches. If we just type in manager, so click on that connector here and start typing in manager, you'll notice it will start suggesting transformers based on what we've typed in. And here we can see the attribute manager. When you find the transformer that you want, you can just double click on it. Now, a little bit more about this quick add. You'll notice that it also gives us a little help entry for this transformer. So you can double check to make sure that this is in fact the transformer that you want. So let's double click on attribute manager and that'll drop in the transformer. Now, when you have a transformer added and it's all connected, you should immediately go into the parameters of that transformer. So I've dropped in my transformer like this, attribute manager. Make sure you've done this as well. If it's not connected, hit Control Z, Control Z to undo what you've just done, and then try adding the manager again, this time making sure that you've connected or selected that feature connector before adding the transformer. So we add in the attribute manager, it is selected. If we just hit the Enter key now, it'll open up the parameters for that transformer. So if we hit Enter, it'll open it up, or if you select it somewhere else, you can just double click on the transformer, just like the feature types. That will take you to the attribute manager parameters, the transformer parameters. All transformers have parameters that you can edit. Sometimes it's just the name of the transformer. The name of the transformer that you see here is the name that will show up in the navigator window. It's often a good idea to give it a somewhat descriptive name, but don't change the name of the transformer itself. This is an attribute manager. That's important information. You may want to indicate what it's an attribute manager for. This is the attribute manager for our parks maintenance data. This can be really handy to know where this data is going, or perhaps even where it came from, so that if I have to find this attribute manager later on in the navigator, it's much easier to do so. And once you have 200 or 300 transformers and maybe 50 or 60 attribute managers, this piece of functionality is handy. So now we see we have all of our attributes, what's on the source, what it's going out to. Now we can start making some changes. The reference park ID we don't actually need on the output. So if I select that here and hit the minus sign, notice it says remove. This is different from hiding the attributes or unexposing them on the source. When you unexpose them on the source, the attribute still exists on the feature. We simply don't see it in the interface. In the attribute manager, when I remove the attribute, it is actually removed from the feature. When you have large data volumes, that's an important consideration because the attributes take up memory. And when you're running the translation, memory is often the bottleneck. If you run out of memory, run low on RAM, FME will start caching features to disk. And when you start caching features to disk, the translation will slow down enormously. So removing that memory overhead, minimizing that memory overhead is important with large data volumes. So we'll remove reference park ID. Park name is still park name. Neighborhood name is no longer neighborhood. Let's edit that. We can just get rid of the name part here. You can also find neighborhood in the drop-down as well because the attribute manager is aware of what's defined on the output feature types. So neighborhood name becomes neighborhood. Visitor count will remove. Tree count will remove. Dog park will remove. Washrooms and special features. So we'll remove all of those. Once you have renamed neighborhood name to neighborhood and removed all of our unnecessary attributes, you can just hit OK. I want to expand the attributes on this transformer. We'll see that we just have park ID, park name, and neighborhood here now has a green arrow. I'll give everyone a moment to finish doing that. Now someone said removed from feature as a question. It's removed as of this part of the translation. As we run the translation, the features exist, the attributes exist here, they disappear here. I can actually demonstrate that. We have the run with feature caching turned on. If I just run to this transformer, notice we have the run from this, run to this. I'm just going to run to this. It's going to read it in here and cache it all and go through this and cache it all. If I click on this little green spyglass here, this is the feature cache, it'll actually open it up in the data inspector. So if I open this up in the data inspector, we can see that it has all of those attributes with values. Reference park ID, tree count, dog park, etc. If I click on this feature cache, this is after it's gone through the attribute manager. Notice that all of those attributes are completely gone. They are no longer defined on the feature. Okay, so now we've done our content transformation for the attributes. We've also done some filtering of the attributes. We've removed some attributes. There's also some features that we're not interested in. Some of the parks are dog parks. If I go back into my data inspector here, not that one, not that one. So in this here, we have our parks. We have our dog parks. I can sort here so I can see the different values. Some of them are Y for yes, it's a dog park. There are in total 7 of them. I just happen to know that. And the rest of them are no, they're not dog parks. The ones that are dog parks, they have a different budget. They're treated differently. So we don't want those dog parks as part of our output here. We want to filter them out. Whenever you're going to filter features, the first transformer you should think of is the tester. The tester performs a test on the attributes, and then the features either pass that test or fail that test. The attribute manager and the tester are the 2 most frequently used transformers. The attribute manager for working on the attributes, the tester for filtering your data. So we want to test the value of dog park. In the manual here, it has us place the tester after the attribute manager, but a quick look at our workspace shows that the way that we've configured this one, it's not going to work that way. If I put the tester after the attribute manager, it can't test the value of dog park because I removed dog park. But that's okay. You can always have the transformers in different orders, depending on what you're doing with them. I do have the dog park here, so I'll simply put the tester before the attribute manager. So let's click on this feature connector, and we'll add in the tester by typing in tester, T-E-S-T-E-R. There we are. There's our tester. We can hit enter to select it. Now that it's connected, we'll hit enter again to go into the parameters. Here's another spot where the name of the transformer is important. I should always leave this as tester. It's important to know that this is a tester transformer, but I should give some indication as to what it is testing. Something simple, so it'll fit in the top here. If you were handed this workspace and you see a tester, you know it's filtering something, but all we see is tester, passed, failed. We have no idea what this test is. So if I make this tester, not dog park, now I know that this is testing dog parks, and the ones that pass are not dog parks. So our left value, this will be the value of the attribute dog park. We can get to that with the little drop down arrow here, attribute value, dog park. So you can choose it that way. Also, if I just type in capital D, it'll suggest dog park. If I make this a little bit larger, we'll be able to see that. So I can go in there, capital D, dog park. This is case sensitive. Lowercase d will not suggest dog park. Uppercase D will. So dog park equals capital Y. No, sorry, the opposite of that. Dog park equals capital N, not a dog park. Dog park equals capital N. I'll give everyone a moment to configure that. And we'll hit OK. Now another little bit of best practices. We've changed the name of this transformer so that it has not dog park. It's a bit clearer as to what this is doing. But now we've got another problem. We have no idea why this is necessary. We're filtering out dog parks. Why should we do that? It's very important for best practices that you comment your code. Indicate the rationale behind it. Why are we doing this? We can add comments either by right-clicking and attaching annotation or hitting Control K for comment. So what I generally do is once I've dropped in a transformer, I've done the configuration, I hit OK, The transform is currently selected. Hit Control-K for comment and indicate why you are doing this particular action. Dog parks have a different budget. Filter them out here. So now someone browsing through this workspace understands why we are doing this particular step. Next up, right now, let's check to see if this is actually working. We'll just run to here. We can see that 7 features failed this. These are all of our dog parks. We can inspect them. So there's all of our features that are dog parks. If I click on this one here, I'll see everything which is not a dog park. If I wanted to see both of those together, I can click on this one up here. That'll inspect the caches for that entire transformer. So now I can see which ones are dog parks and which ones aren't. Now you notice here, everything's green. This is where changing the styling can come in handy. Tester not dog park failed, so those are dog parks. Maybe I want to see what those are. I can change the color really quick. Hit OK. Those red ones, those are my dog parks. That's really the only reason why you should be changing the styling here, is so that you can inspect your data. Now, if I were to run this translation in production, naturally nothing's going to be saved here from this failed port. Those 7 features just disappear. Sometimes it's useful to keep track of them in some way, shape, or form. One option for that is to connect an inspector that will send the features to the data inspector automatically. Could be handy if you're running it and you just have a test where if it passes, maybe that's a bad thing. A terminator transformer is another option that'll fail the translation. Another option is to connect a logger. I'm just going to right click on the failed port here. So right click on the failed port and select connect logger. So that'll add my logger transformer. And now if I run the translation into my logger transformer, what we'll see in the translation log is the information about those features. So it just dumps in all the attributes for that feature. In this case, we can see dog park has a value, yes. This is the Nelson Park dog park, and it drops in some of the geometry as well. So this is just a way of keeping track of some of the features. The logger can be handy for that, especially if you're doing mathematical calculations on a feature. You can run it out to a logger and then quickly inspect that the mathematical expression has been evaluated correctly. Okay, so we ran this, we inspected it, it's all working okay. We can then hit this run from this to run it all the way out to the output. Translation successful. If I click on my output feature type here, there's this inspect button, and I can inspect the final output. So this is what we're getting on the output now. We have our park ID, park name, neighborhood. Notice park area and average park area. We haven't actually calculated them yet, so those are being given null values. Negative 9999 is how null is represented in Map Info tab. Okay, let's talk a little bit more about content transformation. We've done a little bit of content transformation here in that we renamed neighborhood to neighborhood name. But for the most part, we've been filtering the data, filtering out attributes we don't want, filtering out features we don't want. But we can do more than that. The transformers are primarily used for content transformation. This is the transformation of the geometry and attribute values of a feature. So it's important to note what a feature is. A feature is an atom of FME data. It is a point, a polygon, a line, etc., representing a city, a road, a lake, things like that. And on that feature, there can be geometry and/or attributes. The goal of FME is to perform transformation translations. This is different from a typical quick import or export, which only worries about going from format A to format B. Transformation translations aim to maintain the intent of the data. Ideally, no information is lost because of the inability of the destination format to support a specific geometry or attribute type. Instead, the information is transformed so that it can be stored in a different way. There are two basic types of content transformations: geometric transformations and attribute transformations. Geometric transformations change the geometry of a feature, but the attributes are not changed. For example, generalizing a line. Be aware that if multiple features are being combined to form a new geometry, the new geometry will likely have no attributes from the original feature, depending on the transformer. Some other transformers will just grab the attributes from the first feature in. An example of this would be creating polygons from these lines. All of these lines have attributes. When I create a polygon from this line, and this line, and this line, and this line, FME won't know which line to grab the attributes for this polygon from. So it'll either ignore all of those attributes or just grab the first one. Attribute transformation works on the attributes of a feature, but the geometry is left alone. So I can split apart a date into day, month, year. I can concatenate day, month, and year into a date. Things like that. Oh, one other thing I should mention. Quite often in the ArcGIS world, you'll have an area attribute or a length attribute, which is created automatically. FME doesn't do that. If I have a length attribute on this line and I intersect the line at these points, I am basically taking all the attributes from this original line and copying it onto these, child lines. The length will be the same on all of those parts. If you want to recalculate the length, you'll have to use a transformer to do that, like the length calculator. Okay, that brings us to exercise 6. We have our park area and average park area awaiting values. Let's give them some values. I'm going to scroll over here. These bookmarks are really handy for moving your transformers around. So let's add another bookmark here. So let's click and drag a fence over these 3 transformers. And then hit Control B to put a bookmark around all of them. So that's click and drag a fence around this whole thing. Control B to put a bookmark in. This would be really our filter data. So we're filtering out the data here. And then we'll give ourselves a little bit of space between filtering the data and our output here. Now, you'll notice that our workspace is getting a little large for this monitor anyways. I can no longer see my entire workspace. There is a window that we can use to make life a little bit easier. If I go up to the View Windows, in View Windows, there's an Overview window. So I'm going to turn that one on. So that's View Windows Overview. And that'll open up down here, tabbed with my translation log. And here I can see my entire workspace. And the blue is what I'm currently seeing. And you'll notice that I can drag that around. So I can go through my workspace that way. I can get the entire context of my workspace and see just this area right here. Okay, so the first thing we're going to want to create or calculate is the area of our polygons, of our parks. So let's click on the connector here and type in area C. That'll bring up the area calculator. Once you have the area calculator, hit enter to drop the area calculator in. Hit enter again to configure the area calculator. So area calculator, this will be the only one that we have, so we can just leave its name alone. Area calculator is fairly descriptive. There's the type, plane area or sloped area. If you're unsure what those mean, you can always refer to the help. The help also shows up as a window if you want it. So let's go up to, oh, wait, we can't do that right now. Never mind, I'll talk about the help window in just a moment. So we have our type, we have our area attribute. Whenever FME is going to create an attribute, the default name is usually underscore something. In this case, underscore area. That indicates that FME is creating or calculating a new attribute. But on our final output, we don't have it defined as underscore area. We have it defined as park area. So let's rename that right here. So this will be park area. Next up, we have a multiplier. One of the things that you'll notice in the area calculator is that we do not have units. It's not indicating what units it's calculating the area in, square meters, square feet, unknown. For transformers that work with units in FME, the unit will be the unit of the data itself. If you're not sure, you can inspect the data. I've already opened this up in the data inspector once. Select a feature. Up here it has our coordinate system. This is the coordinate system as it's defined on the feature. UTM 83-10. This is UTM NAT 83 zone 10. If I click on this link here, it will give me the full definition of this coordinate system. This is how it's defined in CSMAP. We also have a well-known, OGC well-known text description below that, and the equivalent Esri well-known text description as well. So whichever one you're more familiar with, you can then track down the units, and you can see here that this unit is in meters. Now it is up to you to know whether or not the coordinate system the data is currently in is appropriate for calculating the area. If it isn't, reproject it into something that is. The multiplier then allows you to multiply these units. So right now, this will be in square meters. If I wanted it in square feet instead, I would apply the appropriate multiplier, which is 10 point something. Can't remember off the top of my head. So for now, we'll leave it as multiplier of 1. We'll calculate our area in meters. Hit OK. So we have our area calculator. And notice now our park area has a green triangle. We now have our park area. I'll give everyone a moment to finish configuring their area calculator. Now we need a statistics calculator. Again, let's click on the connector here and type in statistics calculator. There it is, statistics calculator. We'll hit enter. Now don't touch anything else just yet. Let's consider what we have here. Don't click anywhere. When we drop in a transformer, it will connect to the first empty port. In this case, it's connecting to the summary port. If I go up to View, Windows, Help, that'll bring up my help window here. The help window will bring up the help for whatever I have selected. So my help for the statistics calculator talks about the input ports and the output ports. I have a summary, a complete, and a cumulative. The summary puts out a single feature that contains the calculated statistics. That's not what I want. What do the other ports do? Complete gives me all of the features with the calculated statistics, and cumulative gives me all the calculated statistics up to that point, up to that feature in the translation. So the one I want is the complete. I can change what port is connected by clicking on this little question mark here. So I can change that to complete. Now this little question mark is only available when I first add the transformer. When I click outside and click back on, it's not there anymore. So it's just an option when you first add your transformer. If you've missed out on it, that's perfectly okay. We can always just reconnect these things. You can grab your connectors and move them around. It's not a big deal if you forget to click on the question mark. You can always just move these ports around. There, so make sure it's on complete. Now we need to configure our statistics calculator. That brings us to step number 5 in the manual. So step number 5, we will configure our statistics calculator. Let's hit enter. These we'll talk about later on. Attributes to analyze. What attributes do we want to calculate statistics on? We can calculate statistics on multiple attributes. The only one that we want is the park area. And then we have the names of the attributes it will create. Now, right now, it will create all these attributes. We don't actually want all of them. If we blank those out, it won't create them. So get rid of the mean, median, count, sum, range. The mean we want. The mean is the average park area. And we can delete all the rest. There we go. I'll give everyone a moment to do that. So once you have all of that configured, we hit OK, and now we've got green all the way down. So let's run the workspace. Oh, we can run from here all the way to the end, run from this. If I choose a transformer where it doesn't have the cache before it, and I run from this to the end, it'll tell me that it's missing some caches. Do we want to run it with the area calculator in this case? Just run it. So it's actually starting from here and going forward. There we go. And then we can inspect this again, see what our output is. So now we have our park ID, park name, neighborhood, park areas, and the average park area. So now we have all of those attributes. So besides schema editing and schema mapping, transformations of your data, the content transformation is carried out using tools called transformers. It's these guys here. They are similar in concept to the tools in our toolbox. Each transformer does a specific geometric or attribute transformation or some other support function. You can find the transformers in the quick add, or you can also find them in the transformer gallery. The transformer gallery can be handy in that it breaks up our transformers into specific categories. If you're going to be working with rasters, you can review the various transformers here. If you find a transformer you want, you just double click on that and that'll drop it into the canvas. Once you're familiar with the transformers though, it's easier to add them using the quick add. We've always been adding them in connected, but I can always just drop one in and then connect it up manually if necessary. Once you've dropped in a transformer and connected it, make sure it's connected before you go into the parameters. You can double click on the transformer to go into the parameters. I do recommend that you add something descriptive to the transformer name if there's going to be any ambiguity when looking at the transformer on the canvas. If someone came in to look at this, they should be able to tell what's going on at a glance. If you can't tell what's happening at a glance, then perhaps you should add something, like a comment or a name. The parameters button on the transformers is color-coded. It's blue if we've reviewed the transformer parameters and clicked OK. It's yellow if we've never looked at the transformer parameters. So we can see a yellow one here for the logger. We've never looked at the logger parameters. If I go into it, hit OK, that turns blue. Some transformers will have a red parameters button. This means that there's something you have to set in this transformer before the translation can run. Some transformers have default values, which allow the transformer or the translation to run without reviewing the transformer. But others, like say the statistics calculator, notice it's red. There are things I have to set in this transformer before the translation will run. Transformers can have input ports or output ports, or any combination of input and output ports. Some transformers only have a single input port and a single output port. Some have multiple input ports and multiple output ports. The ports are typically named after what types of features are expected to come in and what's expected to come out. For our clipper transformer, this performs a spatial clip. It's like a cookie cutter. The clipper is the cookie cutter, the clippy is the cookie, then you have what's inside the clipper and what's outside the clipper. Some transformers also have a rejected port. We can see that here for the clipper or here on the area calculator. This is where features will come out if they are completely inappropriate for this particular transformer. If I had non-spatial data, tabular data, data without geometry going into a clipper, they would come out through the rejected port. Same with the area calculator. You cannot calculate the area of something that doesn't have any area. So lines, points, and non-spatial data for an area calculator would come out through the rejected port. For the transformer attributes, you can expand these ports and you can see what attributes are coming out of this particular transformer. It's unlikely you'll be able to do everything you need in a translation with a single transformer. You will have to chain them together. We're doing a fairly simple task here. We've already chained together a number of transformers, and that's using transformers in series. Features go into the transformer and then they come out. Transformers can also be used in parallel. You can have multiple streams coming out of a transformer. Here we can see we have our libraries going in an attribute renamer, doing some attribute management here, and then we have some going out to an aggregator. This will create a multi-part geometry. Some going out to a bufferer to buffer the features, some going out to a tester to test the features. With these multiple connectors, a copy of all the features will go along each connector. This is often important to do if a particular action you're going to be doing is destructive to the geometry or the feature in some other way. So creating the multiple streams, very easy. You just click and drag another connector out of it. And we'll see this in just a moment. We can also bring the streams together. That means that all of these features will end up going into this output feature type, this output feature class in this case. This does not merge the features together. If I want to take, say, this geometry here and attach onto it the attributes from these ones here, I have to use a special transformer, such as the feature merger or the feature joiner. You've probably noticed right now that we end up with a feature count when we run the translation. This is a useful debugging tool. If you see features going into a transformer but not coming out, it might be worthwhile reviewing the settings in that transformer or inspecting the data that's going in, making sure it's correct. If you see a lot of features going into a transformer, one feature coming out, and then the translation fails, chances are There's something either wrong with those features or wrong with the configuration on the output, or on what that one feature is going to. That one feature came out, it failed the translation. Inspect that feature, double check the settings on where it's going. Okay, we've got about 10 minutes left. Oh yeah, we should get fairly close to the end here. So let's take a look at why you may want to do things in parallel. In this exercise here, we're going to create some text labels. So first of all, we're going to need an output feature type to write out to. We have one defined here. We can actually reuse this definition. It has all the attribute names that we want. So we can just right click on it and duplicate it. Control D. This is the exact same thing as just copy paste. So I could just copy and paste this, but I'll hit Control D instead, or duplicate, and that gives me my new feature type. It is very, very important that whenever you create a new feature type, you immediately go into that feature type and double check everything. So we've created this new feature type. Let's hit enter to go into its parameters. Right away, we see things aren't quite ideal. The name of our output feature type is now parks maintenance data 00. That's not the name that we want. Let's give this a better name. If I scroll down here, let's see. I know eventually we call it something. Park labels. Let's call this park labels. Park labels. So now we have the correct feature type name. The next thing to look for, especially if you're dealing with shape files or file geodatabase, or well, any of the geodatabases, and most databases, to be honest, is the allowed geometry. To keep things simple for the basic training course, we write out to map info tab because it doesn't care about geometries. So we don't see it here. But if I was doing this with a file geodatabase, what I would see here is a copy of what I had here. It would say that the allowed geometry is polygons, and that's it. That would be incorrect for my park labels. I would have to change that to annotation. Then check the user attributes. They all look okay. Hit okay. So now I have my park labels. Now we want to create our label points. We're going to skip ahead a little bit here to step number 5. The string concatenator, we're going to skip that. So I want to bring in a label point replacer. Let's click on a blank spot on the canvas and just type in label. I know I want to create a label. I'm being presented with 2 options, labeler, label point replacer. Which one do I choose? That's where this little help comes in handy. My labeler interpolates labels along a linear or polygonal feature. Label point replacer replaces the geometry of a label with a label point. I want a label point. So this is the transformer I want. But this here is the troublesome part. Replaces the geometry. I cannot have this in series with my park polygons because my park polygons will stop being park polygons. They're being replaced with a label point. So that's why my label point replacer has to be done in parallel. So I'll connect this side to the output. So we have our label point replacer. We can't go into the properties just yet because it's not connected. If I go into the properties here, I have no attributes available to me. So we can't go into the properties, or shouldn't go into the properties of our label point replacer just yet. Let's connect our label point to our park labels. Remember, you can just click and drag, or you can just click and click to connect it up. So now I'll have 73 features go along this connector, and when I run the translation, I'll have 73 features go along this connector. Now that I've connected up our label point replacer, I can go into the parameters. Let's hit enter. Our label, we can just choose an attribute. I could choose my park name or park area. I actually want both of those. Let's go to the text editor instead. So in your label point replacer, go to label, hit the little down arrow, and hit the open text editor. Brings up this. There's a lot of stuff here. We're just going to focus on this first entry here. This will give us attribute values. These are all of the attributes. So just double click on park name. That'll give us our park name as our label. Hit enter for a new line. So that was double click on park name, hit enter, give it the park area, or it's going to give us the value of the park area. And I can just put in space square meters, so then I know the units. And okay. So I'll give everyone a moment to configure that, just like what you see there. I'll hit OK. Label height, again, this is units of the data. So this will be 25 meters high that we want. So it's not in points or anything like that. This is in the units of the data, which is in meters. Hit OK, and now we can run this part of the translation. So now I'll have my label points. I can inspect that. Remember, you just click on those little play buttons over top of the transformer. That gives me all that. I don't see the parks though. Kind of wish I could see the parks there. Now, you've noticed that every time you click on one of these, it opens it up in a new view. If I want to compare it to the complete there, that's in a different view. We've got this one on top of the transformer, but that just gives us the transformer one. So here's the trick. I can click and drag a fence over both of those. Right click and inspect the cache features. It'll show me all of that. So now I have my points and my parks. Well, my label points and my parks. And there I can see it is a park name and the area in meters. So we've got about 3 minutes to go. I think that might just be enough time to talk about group by processing, and then that's all we need from this tutorial. And tomorrow we'll move on to more advanced topics that you'll be using on days 3 and 4. Group by processing means a transformer groups features based on specified attribute values and performs the transformation on those individual groups. FME transformers carry out transformations on either one feature at a time or on whole sets of features at once. For example, if I look here for the area calculator, as each feature comes in, the area is calculated, the feature is passed out. Statistics calculator, this is a blocking transformer. It has to stop all of the features until they're all in there, and then it can pass them out. I can also group by features. Basically, it means that the operation is only performed on features that have the same attribute value. In this dissolver, for example, by default, it would dissolve everything that comes in. It's going to block all the features, make one big group, and perform the dissolve. But perhaps I only want to dissolve features together that have the same view description value. When I group by view description, it would then only dissolve together features that have that same value. It creates separate groups for each unique attribute value. So let's see this in practice. We have right now one group coming in. but it's decided we actually want the average park size, not for the entire data set, but for each neighborhood, based on the neighborhood attribute. So what we can do in the statistics calculator, let's double click on that, and we're going to group by neighborhood. So go into the statistics calculator, go to the group by, click the three-dot button, and choose neighborhood. So we're going to group by neighborhood, hit OK, and now I can just run to this. So it's the first green button. Notice the summary now, instead of being 1, it's now 6. When I inspect that, I now have a separate calculation of the mean for each neighborhood. And if I run this all the way out to completion and inspect this, now I can see I have various different average park areas. It's the average park area for each neighborhood. And that's the group by. Coordinate system transformation, I seem to recall that for what you'll be doing, all your data will be in the same coordinate system. So I believe we'll be skipping over this. If I turn out to be incorrect about that, we'll circle back at a later time. So that's it for today's tutorial. Tomorrow we'll be doing a deeper dive into some of the more specific pieces of workbench functionality.